So we were discussing local area network, where if we want to connect some computers in our home, we will prefer to go via local area network setup. In the LAN, we get or within one building, we get very high speed, and it is highly secure as we are directly in control of the system, and the connection is pretty one-to-one, and it is a very secure system. Hardware which will be need to do the local area networking is switches, routers, Ethernet cables. These are some hardware will be needed to connect within the local area network. If we want to connect more than one building or house, then usually for a city level wide, we do a metropolitan area network. It is a large network which can span multiple buildings. In this particular type of network, we get moderate speed, and the security is moderate, as the security wise, the physical security is also a concern. So that also come into play. So the security is a moderate. What we need is a hardware like Ethernet cables, and within each building, there will be a LAN network. In that, switches, routers, etc. will be there, but within from one building to other building, we can connect via Ethernet cables or other coaxial cables. The third type of network is a wide area network. It is not restricted to a geographical location. In the wide area network, we get low speed, and the security is also lower. This can be done via router or optical fiber or via satellite link. The setting of wide area network is possible. Now, another topic is network topology. So network topology, what we mean is when we are connecting computers or network devices, how are we going to connect them? And connection can be both physically, like I am going to set up computers in what configuration. Physically, it can be directly connected, or it can be connected in star configuration using the cables. But there can be a logical or internal connection, and where the devices communicate internally. So physically, network topology may be something, but internally, when they are connecting it, the topology might be something else. So today we are going to discuss about the physical network topology. So there are 7 different type of topology, ideally 6, but point-to-point network connection is also considered a topology. So first one is a point-to-point, where we directly connect the network from one to another one. That is pretty simple. But then another topology is there, a bus topology, where there is a main trunk is there, and different computers are connected via the T connectors. And the informations are getting, if it is transmitting the data, the information available to others as well. Then there is a third topology, which is a ring topology. So in this kind of network, what was happening, the collision was happening in the packet, and the packet dropout was issue. So this kind of topology, I'm talking about 80s, 70s, and 90s time when they were being used. So to avoid the packet dropping, what they decided to, let's connect the network in a ring formation. And in the ring formation, at any point, and there is a direction, at a particular direction, the data is going to get transmitted. And the transmission of the data will be based on a token. Just like when we play a captain ball game and we decide, or musical chair, we decide to rotate in a certain direction, and any point of time in the chair, one person will be sitting when the music stops. So here also, the person who has a token, that computer only can transmit the data in a particular direction. So this helps in avoiding the collision of the data and packet drops. But this was also not enough, because more and more people started having more and more computers, and companies started requiring a different kind of way to connect them. So they found that star topology. So in the star topology, there is a central networking device. It can be hub, it can be router, it can be switches. And with that, the different computers will be connected to it. So in this case, also you see the physically it look like a star, but at any point of time, if this person wants to talk to this person, it is internally, it is sending the data here, and then directly is going to this computer. So internally, logically, it is actually a bus topology, but physically, it is a star topology. People needed a different kind of requirement when the requirement changes. So some thought that tree topology is okay, where the central one is again the main trunk, and what connecting with the T junction to it. There can be other small network. So this all kind of topology had some collision problem, and if it is dedicated network was not there, people now wanted to avoid the they want to have a direct connection to the different computers. So mesh topology came, where each computer is connected to every other computer. There are partial mesh topology where some are connected, some are not. But because of this direct connection, this computer can talk to every other computer. And there is no delay or no problem in data dropping. But this is good if we have a small type of small size of computer to be connected. Imagine if we need a 1000 over computer to connect. So amount of cable mess, and if some failure is there at some places, how to find which cable is faulty. So that could be a problem. Then there are hybrid topology. People already have connected with a ring. Some places ring is good, some places star is good, some places bus is good, but they want to connect various clusters, network cluster. So the hybrid topology came. Now let's to know more detail about them. So if we go for the mesh topology, as I said, each computer is connected to every other PC. So in this case, if this computer is connected to all, there are too many network cables are there. So redundancy of the cables are there, and they will be all the time getting connected. So redundancy is there. This kind of connection is mostly used in a wide area network, where we are connecting one city to another city. So in that, they are connected directly with the cable. But if we are going to do within one building, which has thousands of computers, it is going to be very complicated, the mess. The simplest one is a bus topology, where a central bone is there. Central bone is there. Let me see. Mouse. So central bone is there, and other net computers are connected with a T junction. Okay. Now there are they can be connected with the coaxial cable, the 10/2, 10/5. So 10/2 has a connection limit of 185 meter, means up to 185 meter, the data can be transmitted if it is a coaxial cable of 10/2 type. And after that, if you want to send the data, then a repeater will be needed. It was popular earlier, but nowadays not much popular, coaxial cables. For bus topology, the cable requirement is very low. As we can see, if computers are kept closer to the main trunk, the cable requirement is very low. But the main problem with this is that if this computer is sending the information, every other computer can see the information, because there is no way to tell which computer to will send information to which one in this particular case. So the data is available everywhere. And another problem is that if the main cable get faulty, the whole network can go down. So if it is faulty here and data coming from this place, whole network can go down. But if it is a fault here, then these two computers can still interact, but more or less the performance of the network will not be good. In star topology, I have said the centrally there is a hub or switch or routers. With that, computers are connected. Each device will require a single cable point-to-point connection between the hub. So this to this, there is a point-to-point connection. This to this, there is a point-to-point connection. And star topology is the most popular topology. Most of the places we will see people are using star topology to connect computers. And in this particular case, if there is a failure happen, it is easy to detect. If this computer cable get failed, it is easy to detect that this cable is faulty, and troubleshooting is very easy. And adding a new device is also easy. Let's say our router or hub switches has more ports available. Like currently, this is 5 PCs are connected to this. Now, if it is an 8 port, so we still have 3 more ports to get connected. So we can add 3 more devices. If it is a 48 ports, then we still have 43 more connection points in this hub or switch or routers. Now, the ring topology. In this case, I was mentioning earlier, the data travel in a circular fashion, usually anti-clockwise. And it is mostly wired in a, so the wiring is physically it look like a ring, but wiring is done in a star topology, means there is a central connection, hub or switch, and they each get a token to transfer data from here to here. Due to token, it can avoid the collision, but now more and more advanced topology and networking devices are there. So ring topology is not very popular nowadays. Then hybrid topology, which is a combination of one or more topology. And then there is a tree topology, which is a combination of star topology and the bus topology. In this, new node can easily be added because the trunk is there. We just fix a T connector and new nodes can be added and new set of computers can be added. So far, okay? So far, okay? Can you, the voice and everything is okay? Thank you. Now the subnetting. Subnetting is a concept where you are going to do in the lab when you are going to set up the virtual private connection, and within that going to do the subnet connection. So why the subnetting is required? So initially the Internet Protocol version 4 had a limited number of IP address can be defined. So it has a limitation. So the IP address were very expensive. Getting a public IP address was very expensive. And have you studied a computer network like class A, class B, class C type of network? Any idea, and anyone who doesn't know class A, class B, or class C type of network, IP connections? Like 10.0.0.0 is a class A, 192.0.0.0 is class C. So have you, do you have an idea about the class A, B, and C network? So, okay, so the class A and B and C is not available, not known. So in the next time, I will be taking you through the class A and B and C, because when I'm going to take the example of subnetting, then the class A, B, and C information will be required. So currently we are only understanding that, let's say if we have a network connection, IP address available to a company, and uh, and it is depending on what class of IP address we have. For every IP address, there is a price needed to be paid. So let's say I have a class C type of IP address, and for class C type of IP address, the maximum connection I can do 254, because only 8-bit is available for doing the connection. So so it is ideally 256, but the two connection goes away, start and end. So only 254 is available. So now if my organization has more than 254 computer or devices to get connected, then what we are going to do? So in that, to solve that particular thing, the subnetting concept came. So basically in a subnetting or subnetwork, we are logically dividing an IP network. So we get an IP network, and with the same IP network, we are dividing it to so many parts that we can use it with the same IP network. We can connect to other computer network within our network. So in this case, we divide the network into 2 or more networks, and that is called subnetting. Subnetting can be of 2 types as per the host requirement. So the case I said that my company had more computers to get connected. So that is a host requirement. So based on the host, we can do the subnetting. But then our network provider can have also a condition that we don't have enough network to provide. So they may do a subnetting as per the network requirement. So this, I was supposed to take an example, but subnetting require a little detailed discussion how to calculate the subnetting and subnet mask. This I will be doing in the next one. Let continue this subnetting topic in the next Friday class or in the colloquium. Now, when we go to computer network, so when we say computer network, any book, if you read, the famous book is Tenenbaum, Computer Network, or any other computer network, if we read a theory book, and the first stage only, they will say that there are 7 layers in open system interconnection protocol, OSI model. So in the OSI model, like whatever we are, whenever we are doing a network connection with one system to another system, we all do this mobile way. We are sending the data in the internet. So when we are doing interacting with the internet, as we see HTTP, or we are doing a file transfer using an FTP protocol. So HTTP or web browser, they all stay in an application layer. But below that, there is a presentation layer, like banking transaction, etc. They have a secure socket layer. They are using the 6th layer. So the lowest layer in this case is a physical layer, where the coaxial cable, wireless, fiber, hubs, repeaters are used. Then the second layer is the data link layer, where Ethernet, frames, switch, bridges are there. And third network is packets, where the routers and layer 3 switches are there. But other than that, TCP/IP protocol or UDP protocol will be in a transport layer. And the APIs, many times you see when you go to browser, can we store the session? Can we show the session? So they are storing using this session layer. So all these are based on international protocol, and it is available whenever in any internet way or any connection way we are providing. So it is a concept of networking layers and computer network. So today we are going to talk about hubs and repeaters, which is a layer 1, which act in the layer 1. And then we will talk about the switch and bridge, which actually act in the layer 2 data link layer. And then router is in the third layer. Gateway, usually the application gateway people uses, so that is in the 7th layer, or even layer 4 gateway, layer 5 gateways are there. So let's see what are they. So next we are going to have the hub repeater bridge. I don't know how much I can cover in next 15 minutes. So whatever remaining, I will be recording it and make it available. So let's go for hub. What is a task of hub? Here we are talking about the network hub. In hub, it only does the job. It transfers data from one computer to connect it to another computer. Means it cannot recognize what is a source and intended destination of the data. Practically, if I have connected two computers or multiple computers with a hub, then the computer which is sending the data is simply going to send the data if it is connected via hub. It will not be able to understand what is a destination, so it is simply transmit the data. And hub can be used both for transferring the signal, which is analog data, or it can be used to transfer the digital data, bits data. Now, it is a half duplex type. That means if the two devices are there connected, if they both can talk to each other simultaneously or concurrently, it is called full duplex. But if one side can talk to other side, that time the other side cannot talk to it, that is called half duplex. And there is another called simplex, where one can only send data to other side, from other side data cannot come in. So this particular in hub are actually half duplex, in that if one computer is sending the data to another computer and it is connected via hub, at one time only one system can send data. Now, since it is in the layer 1, it does not store the MAC address, the network ID the computers have. It does not store the MAC address. And the task of hub is to always broadcast. Since it transfer data from one to one, it only has single collision domain. So if data will come from other side, there will be collision. So means if multiple computers are connected via the hub, and everyone is transmitting the data from this, if this computer has many computers connected via hub, and other computer is also sending the data, so the collision is going to happen in this case. Hub, where it is used in the local area network, where let's say in my home, not much requirement is there, my computers are connected directly to another computer or another networking device. So in that case, I don't worry about the complication. So it is usually used in the LAN devices. So far, I talked about the passive hub. Means there are two types of hub. There are active hubs and the passive hub. Passive hub does not require electricity. Its task is just to transfer data, whatever it received, to the next. So in passive hub can be very useful where the electricity connections is not available and we still need to transfer the data or connect the data computer to computer. So in that case, passive hub is there. But there are active hubs. What active hub can do, it can actually enhance the data, means it can regenerate the data. So it can be, means if we are connecting computers with active hub for longer distance, then we want to connect to the next computer. So while transmission, the data can be lost if the distance is longer. So if it is an active hub, it can regenerate the data, it can amplify the data, while passive hub is simply going to transfer the data. It is not going to regenerate the data. Passive hub does not require electricity. Active hub will require electricity. And this is an example of a hub. Networking devices more or less will look like a box type and this RJ42 connection type. But if we go and read the specification, we will know it is a hub or a repeater or what. Next is a repeater. Repeater job is very simple. It is just to amplify and transmit the data for a longer distance. So repeater does regenerate the data, means if the data transfer like 0, it is going to, if it is get lost while the connection, then it is going to regenerate and then transmit to the next. If it is a 1, then it is also going to regenerate it to the 1 and then shift it. So there are many types of repeater, like telephone repeater, where in the past telephone lines needed to have a repeater because the homes were in a very long distance and data can only get transmit a certain distance. So at a certain, after every certain interval, repeater were needed for data to get transmitted without a loss. Similarly, optical communication repeaters are there, radio signal repeaters are there, analog repeaters are there, and digital repeaters are there. It also acts in the layer 1. So in layer 1, it does not have information of MAC address. So it also doesn't store a MAC address. We might have seen or use a Wi-Fi repeater in our home to extend the range of our Wi-Fi signal. So they are also the repeater of Wi-Fi repeater type. If it is a physical repeater, then it is used in the local area network. And there are many types of repeaters are there. If we are talking about the 10-base-2 type of cable, which has a range of 185 meter. So usually if it is a coaxial 10-base-2 type of cable is connected, so after every 185 meter or before that, another repeaters are used to keep the data intact and then send it to the next point. The next networking device is a bridge. What bridge task is, it tries to connect 2 segments. And by doing the 2 segment connection, it reduces the traffic on the local area networks. Let's say if we are in a Tromsoya and we want to connect to Tromsdalen. So there is a bridge, right? So it is like that kind of bridge. And if we have the, let's say bus goes from Tromsoya to every place in Tromsoya, and the bus in the Tromsdalen goes every place in the Tromsdalen. And there is centrally to cross the bridge, there is a car or any kind of cable car is there. So people, not everyone is going to cross Tromsøya to Tromsdalen. There are many people who are going to be in the Tromsøya only, and many people want to be in the Tromsdalen only. And if they want to cross it, there is a bridge is there which by which they can cross it, and then they can go. So bridge can help divide this, the network into segments, and that's how it reduces the traffic on the network or LAN. But bridge is not dumb like hub or repeater. It is inspect the traffic and decide whether it want to forward or it want to reject it. Now, how it does, it checks the source and the destination MAC address. So to do it, let's say if people, if the message comes that to the Tromsøya network point that I want to send this to a certain address, which is in the Tromsøya. So bridge will automatically know from the pin code that this belongs to this part. So I don't need to send this information to the Tromsdalen side because the pin code is, it says that it is to the Tromsøya. So if any information or a letter is there to send, the bridge is say, no, this will not go cross the bridge, and it will go to the Tromsøya side. So that is what it can decide on the traffic, whether it want to forward to the next network connection point or not. So it is the layer 2 device in the OSI model. It is used to connect the multiple network segment or LAN segment. It filter the data traffic. since it has a it has a two collision domain. So it's not like a single collision domain. So there are two entry and exit points are there. So the chances of collision and packet drop is less compared to hub in bridge. And if you want to see the bridge type of bridge look like this as the picture below. Now next comes the switch. So all these things which we are reading, it is a networking devices which as the people needed what to do to solve their problem, different kind of devices came. So it is a history we see for the networking devices also, that as the things becoming complex and complex, the better and better solutions are coming up. And but why can't we use the most advanced device to do this? Because most advanced device will be expensive. If we can do some tasks with 10 krona device or 20 krona device, why I want to spend 2000 krona device on a device? So the next network devices which is used in the data center or networking connection is a switch. Switch 2 is a layer 2 device, and it is a full duplex. That means at any point, both sides the communication can happen. So they don't have to wait. Okay, I have transmitted the data has been received. Okay, now you can transmit. So they don't have to do this kind of acknowledgement and wait. So in this, the communication can be in the both way. Now it does maintain the CAM table. That means it content access memory table, and that is how we decide where to send and what not to send. But for the very first time, it is going to broadcast to every one of them because it does not have the MAC address of all the devices connected to a switch. But after it makes its own CAM table by transmitting some time from one computer to other computer, it will be able to know which side or where to transmit the data because it will have the MAC address. So the transmission can be both unicast or multicast. That means it can send to one computer or it can send to multiple computers at the same time. And in the switch, in every part, there is a separate collision domain. So the packet drops doesn't happen in a switch because a dedicated pathway is there. So one computer is sending data to another one, the chances of packet drop is very, very low. But it has one broadcast domain. Switches comes with different kind of port configuration, as you see below. It is a 48 port switch. That means 48 different kind of computers can be connected to it. Wireless switches are also there, which is slow, 10 Mbps. But if it is wired, 100 Mbps connections can be done. But nowadays we see 1 Gbps, 100 Gbps. So in those cases, the switches are not needed. Something else is required. So people, if the requirement is 1 gigabyte per second connection, so the type of cable will be different and type of networking devices will be different. But if my requirement is up to 10 Mbps, 100 Mbps, then switch is sufficient to get it connected. So it's based on the device. Now in the switch also there are 4 type of switch. Basically there are 3 type of switch. The 4th one is a combination of all the 3. So first type of switch is store and forward switch, where what it does, it buffers and verifies each frame before it forwarding it. Since it verifies the data, and that's why it is slow but reliable. In the switch, what is it does, it has the ASIC connection, integrated chip connection at a application specific integrated circuit. So that's how it can do this decision very fast. ASIC is a very fast type of means if any algorithm we are able to implement in the ASIC, it is one of the fastest way to implement it. It is slow but reliable because it verifies before sending it. Now there is a cut through switch. It reads only up to the frame hardware address means where it want to send. It does not verify, it only try to know where is the address. It doesn't do the error checking. So it is a faster than the store and forward switch. And there is a fragment free switch, which only checks the first 64 bytes. And what it does, it attempt to retain the benefit of both store and forward and cut through. That means it does a little bit of verification, and it only check the address, hardware address, and forward it. But people want that I want a combination of at different point of time or for a different task, I need 3 different type of switch. So there people came up with adaptive switch. It can change automatically depending on requirement, that what type of store and forward I should use it, or cut through I should use it, or fragment free I should use it. So it can automatically decide. This is the most expensive type of switch. Finally, there is a router. There is a next one is their gateway. So router is a layer 3 device. Means it is in the, if we go to what is a layer 3, is a network layer. So router is use a network layer 3 of the OSI network layers. It is mostly used in the wireless area, wide area network. It can connect 2 or more networks, and it is not a networking device. It is an inter-networking device. So the difference is there. Networking means we are connecting between one computer and another computer. But inter-networking means we are connecting between one cluster of network with another cluster of network, or one type of network with another type of network. So this is an inter-networking device and not a networking device. In router, every port has its own broadcast domain. So if router has 2 port, 4 port, or 8 port, every port can do the broadcasting. And we have seen in our home, these wireless routers are there, where depending on its capacity, how many net connection it can do. And it also has some physical port, and it also have a logical connection antennas. Since router is in the work in the network layer, and in network layer IP addresses are available, so it uses the IP address, not the MAC address, or not dumb like the hub, which just simply transmit the data. So router is an intelligent device. It uses the IP address, and it sends the data in the form of packet, not in the form of frames. If we are sending the data using the layer 2 device, we are actually sending the data as a frame and not as a packet. You can ask about, means we can further touch what is a frame and what is the packet in subsequent classes if it is needed. Router does maintain the routing table. Routing means root, means router word comes from the word called root. So it is a root decider. So if we have a router with internally, it is connected, internal there is a dedicated connections are there. So in this, it can decide which route it can go, which computer it can send. So it does using the routing table, and routing tables are like, we have a Excel sheet, and the first column has a port number, and the second column will have the corresponding IP address. So initially it doesn't have the routing table, but as the networking connections, it does more and more interaction with multiple computers connected with the router. It makes its own routing table, and that's how it can decide if, okay, the IP address 1 want to connect to the IP address 5. Okay, I send IP address 1 to IP address 5, not send 2 through 2, 3, 4, or 7, 8. So it can maintain its routing table. That's how it is an intelligent device. Routers can be very fast, like 10, 100 Mbps in a wireless mode. It can be Gbps to 100 Gbps. If it is a wired mode, there are 100 Gbps routers are available. And routers are the most expensive device so far, whatever we have gone through today's lecture, like hub, bridge, switch, or repeater. Finally, the gateway. So gateway is a simple thing. It is a connecting device to connect between the two networks which are not talking in the same protocol. Means when we are connecting to an internet service provider, they give the internet connection to a particular point to, let's say in UIT, if we are talking about the internet service provider to UIT or to our home. So they give a network to a particular point. So there is a gateway connected to it, and gateway can be both, and gateway is a layer 4 to 7. It works on the layer 4 to 7. But that currently I'm talking about the internet gateway, that is a layer 7 one. So in gateway, data comes or connection comes. After that, the router and the modem and hub and the switches are there. But it is used, what gateway does, it convert the format from one format to other format so that two of the network can talk to each other who are talking a different language. It is basically an entry and exit point, and we can have a firewall gateway, we can have different types of gateway, physical gateway, software gateway. And most of the gateway operates in the application layer. Like when we do a banking transaction, the SSL is a layer 6, and that we can have SSL gateway there. It's a matching point between a dissimilar system. It does the conversion of the format. So with this, we are going to finish today's. I hope it was useful for you to know about different kind of networking devices. Just to give you a highlight, this networking devices will not be a part of final exam, but getting to know the gateway, subnet, all this topic will be helpful for your lab and other case study and tutorials. So do you have any questions? Do let me know. Otherwise, we have already crossed 1 o'clock, and today's class time is finished. We can see you again on Thursday with continuing the introduction to cloud computing. So is that okay? If you have any other question or any other topic on the networking you want to know, we are going to cover on the OSI layers in a little detail, and also calculating subnetting mask and subnet, and probably virtual private network, what is a VPN, because those are the things available in Azure. And a lot many times, if people are working as an architect or a network architect in a company using the cloud platform, having a better knowledge of VPN, subnetting, etc., will be useful. So thank you all. If you have no question, then we can end this class. Thank you very much. Bye-bye. See you next week. See you next week. Bye-bye.